Hello everyone, I welcome you all to Chemistry Voyager YouTube channel. In today's session, we will try to cover the preparation and properties of benzene diazonium chloride. Let's get started. So for the preparation of benzene diazonium chloride, we require aniline as the starting material. And when this aniline is treated with sodium nitrite and hydrochloric acid at a very low temperature, that is 0 to 5 degrees centigrade, we will immediately get this benzene diazonium chloride. Benzene diazonium chloride is a very good starting material for the preparation of various aromatic compounds. As you can see from the slide, benzene diazonium chloride on treatment with fluoroboric acid is giving you fluorobenzene, and on treatment with the cuprous chloride it is giving chlorobenzene. First and foremost, it is very important to understand that it is always the negative part of the reagent that is attacking the benzene diazonium chloride and giving you the corresponding product. For example, if you treat benzene diazonium chloride with the fluoroboric acid, the negative part of it is F minus, and this F minus is attacking this particular carbon and is giving you this particular compound. The reason for the attack of this F minus on this particular carbon is that this nitrogen is positively charged and it is always trying to take this bond pair of electron towards itself, and it will be immediately eliminated as nitrogen. And same is the case with cuprous chloride. The negative part of cuprous chloride is Cl minus, and this Cl minus will now try to attack this carbon where this bond pair of electrons are taken by this positively charged nitrogen, and nitrogen gas is evolved. And the same is the case with all other cases. In all the cases, there is evaluation of nitrogen. And when you take cuprous bromide, the negative part is bromide ion, and that bromide ion will now attack this particular carbon and will give you the corresponding bromobenzene. And if you add potassium iodide to benzene diazonium chloride, it will give you iodobenzene. Similarly, with water, it will give you phenol because the negative part is what? OH minus. If you add H3PO2, H3PO2 is a very good reducing agent because it is capable of generating good number of H minus ions in this fashion. So this H minus can now attack this thing, and eventually you get what? Benzene. If you add KCN, the negative part is Cn minus, so that you get cyanobenzene. Basically, benzene diazonium chloride can undergo two types of reactions. First type of reactions are type of reactions in which there is evaluation of nitrogen gas. We have already seen some examples corresponding to that. Coming to the second type of reactions, benzene diazonium chloride can also undergo coupling reactions. In coupling reactions, there is no evaluation of nitrogen gas. Rather, the final product retains the two nitrogens. When we carefully look at the first example, where the benzene diazonium chloride undergoing coupling reaction with aniline, the course of the reaction is like this. The lone pair of nitrogen will be in conjugation with the benzene ring, and the para carbon is going to couple with the electrophilic nitrogen on the benzene diazonium chloride. And this nitrogen is electrophilic in nature because the positively charged nitrogen on the other side is going to take this pi bond. Thus this particular nitrogen is becoming electrophilic, and this electrophilic nitrogen will be coupled with the para carbon of this particular aniline, and so you are getting this particular compound. The name of this compound is para amino azobenzene. The color of this compound is yellow dye, and this particular compound is generally called as aniline yellow. This is also referred to as what? Aniline yellow. And same is the case with the second reaction. In second reaction also, the lone pair is in conjugation with the benzene ring, and this para carbon is coupling with this electrophilic nitrogen. This is electrophilic because this pi bond is taken by this particular nitrogen, and the product is para hydroxy azobenzene. The color of the compound is what? Orange dye. And the main difference between the first and second reaction is that the first reaction requires acidic medium where we need to maintain a pH of 4 to 5, and the second reaction requires a pH of what? 9 to 10, meaning that we need to maintain some basic, we need to take some basic medium. So if you have observed carefully from the previous slide, the most preferential site for the attack of the electrophilic nitrogen is always the para carbon because of some steric reasons. So this electrophilic nitrogen always prefers to attack this particular carbon. But what if you are given with compounds like paracresol where the para position is blocked? The para position is blocked, right? So in this case, the electrophilic nitrogen need to find some alternative like this orthocarbon. So when the para position is blocked, the electrophilic nitrogen is going to attack this particular ortho carbon, and the course of the reaction is going to be same. The lone pair will be in conjugation with this benzene ring and this pi bond, meaning that this ortho carbon is going to couple this electrophilic nitrogen, and accordingly you will get the product. The second reaction is called azodite test. The requirement for the azodite test is that beta naphthol and benzene diazonium chloride. This particular compound is called beta naphthol because the carbon next to the phenyl ring is alpha carbon and the next carbon is going to be beta carbon. And the same is true for here. That is, the carbon next to the phenyl ring is alpha and next carbon is beta carbon. So the preferential site for the coupling reaction between this and this is what? This particular alpha carbon. And the reason for this alpha position for coupling reaction is that this give rise to some stable intermediate during the course of the reaction. And the final product, the color of the final product is orange color.